Hello, everyone. My name is Ian McLaughlin, and I just finished my PhD in neuroscience at the University of Pennsylvania. And by the way, I just learned that my diploma was sent in the mail. So before long, I'll probably try to find a place to put it behind me somewhere, so you won't immediately doubt my credentials. And well, hopefully, look my name up on Google to make sure I am who I say I am. It's something you should always do when you encounter someone on the internet claiming that they have various credentials. Okay, so I like to spend the first 15 minutes or so talking about a specific topic on YouTube before starting a live conversation on Twitter, where the conversation is driven by, whatever topics might arise by whoever happens to be there at the time. And most of the folks with whom I interact are on Twitter, but I've been trying to prioritize YouTube comments, so feel free to bring up topics in the live half. Okay, so I should let you know that my 1-year-old has developed a bit of a vocabulary at this point. So you might hear, her yelp them out in the background, and she has a very consistent passion for books. And books is actually one of her favorite words. Book is one of her favorite words. So you might hear her exclaim her desire to read a book when she gets back from her walk as well. All right, so to be honest, I was hoping to talk about something else today, but it just turned out to be too big of a topic for me to cover in the time that I had available this past week. To be honest, once again, I've been applying for a few jobs over the past few weeks, and between that and the baby and visiting the lab a few times to work on experiments, I just didn't think I was going to be able to, to do the topic justice. I was hoping to talk about Wim Hof and the Wim Hof method, but there's just like a lot to unpack there, not the least of which being the fact that he's not the only Northern European who's currently evangelizing the benefits of exposure to cold temperatures and specific breathing techniques to combat a variety of maladies. Also, I learned that this new Netflix show that's created by Goop, the company that Gwyneth Paltrow owns, did an episode devoted to Wim Hof. And, between the history of Wim Hof, as well as the available research on the biology underlying the claims he makes, I just want to make sure that I'm fair and comprehensive in my evaluation. Everything from the basic science of why it is that some people are capable of tolerating much colder temperatures than others for long periods of time, to the biology underlying the effects and potential benefits of cold exposure. And, I'll be honest, at least one part of my motivation for diving into this topic is that if I were to pick like an ideal temperature for our apartment, guess who just got back? If I were to pick like my ideal temperature for our apartment, it'd be something like 67 degrees Fahrenheit, or like that's around 19 degrees Celsius. Well, my wife would probably pick something like 87 degrees Fahrenheit, or about 31 degrees Celsius. And, I'm sure we're not the only married couple that encounters a bit of disagreement on temperature. But I find, research into exposure to temperature extremes to be quite interesting. And I'm particularly interested in any arguments on behalf of keeping things colder whenever possible. Anyways, so I'm close to wrapping that up, but I'll need a bit more time in lieu of a discussion of Wim Hof. However, here's what I have for you. So there was a preclinical study that was done to try and figure out if it might be possible to extend the fertility of females as they get older. And, this was a very big group of scientists, many of whom are at various institutions in Australia, like, various groups at the University of New South Wales in Sydney. But then some are at Harvard, at the University of Limerick in the Republic of Ireland, and the National Institute of Neuroscience in Tokyo in Japan. So the point being that this was a fairly substantial number of scientists, and I'd just like to note that one of the listed scientists is David Sinclair, who's originally from Australia and is a highly accomplished scientist. The baby wants her mom. But who doesn't, right? Okay. So David Sinclair is this highly accomplished scientist, and he's a professor at the Department of Genetics and the co-director of the Center for the Biology of Aging at Harvard Medical School. And, I should note that I have a podcast called Wired to be Weird, and we have a whole thing devoted to very interesting and provocative projects focused on extending overall human lifespan and health span. And the only reason I bring this up is because David Sinclair is sort of like a central player in this story. And, the short story here is that he's one of the leading scientists who are pursuing solutions to the problem, the challenge of aging. And so in any case, he's one of the supervising scientists on this paper that's devoted to extending fertility. And there's a good reason for this. The study revolves around the role that a specific biomedical factor, or biochemical factor, I should say, called nicotinamide adenine dinucleotide, or NAD, plays in declining fertility in females throughout aging. And so, this is a topic in biochemistry that can involve like a ton of jargon that's fairly indecipherable. It's one of those things that basically anyone working towards their PhD in any biomedical field has to study at like a fairly granular level, but will typically just jettison it, from their memory unless their own work involves these pathways. But so for our purposes, you can think of NAD as a kind of biochemical pathway that fuels the reactions of other biochemical pathways. You can sort of think of ATP if you might be familiar with that molecule. And when I say biochemical pathway, what I mean is that our bodies are composed of a huge variety of different cell types, skin cells, muscle cells, neurons, and they all have a ton of different molecules within them that participate in a variety of interactions. And so, you can think of like a set of standing dominoes arranged, to tumble. And so, I'm sure you've seen like the mesmerizing videos of like the gigantic arrangements of dominoes, or like the little plastic rectangles that are about the same size as dominoes, that create an amazing series of interactions that will result in some, surprising picture or consequence. And so, picture like a string of dominoes that then breaks into separate strings of dominoes, right? So, when one of them falls, several different strings of dominoes begin to proceed. And so, that's kind of how NAD functions. It basically enables a variety of other biochemical reactions to occur within our cells, just like the tumbling of a single domino can result in multiple diverging strings of dominoes to begin to tumble. So, in other words, certain events that occur within many of the different types of cells in our body rely upon NAD to occur. And so without it, those chemical reactions can stall, so in the absence of NAD. And so, the only reason I like belabored this whole NAD thing is, because this study focused on influencing levels of that molecule to evaluate effects on fertility. So, for folks who are, trying to have kids, female fertility tends to be one of the like central concerns and can be a limiting factor. And so, at the moment, there aren't any effective ways to rejuvenate oocytes during aging. And oocytes are basically like the precursors to egg cells, which are the things that, need to combine with sperm cells for fertilization or, to create a zygote. So the goal of this study was to see if there might be a way to help women who are, getting older to sustain fertility without any kind of invasive procedure. So, ways to provide more alternatives to things like in vitro fertilization. And so, as David Homer, a professor at the University of Queensland, said, quote, "Quality eggs are essential for pregnancy because they provide virtually all the building blocks required by an embryo." So, they were working with mice, and they provided a precursor to that early domino in the biochemical cascades, NAD, with a precursor to NAD called nicotinamide mononucleotide. That's typically called NMN. So I know there's a ton of abbreviations and initialisms here, but just think NMN can be converted into NAD. And so, so here's what they did. So quoting, Professor Homer once more, quote, "We treated mice with low doses of NMN in their drinking water over 4 weeks, and we were able to dramatically restore egg quality and increase live births during a breeding trial." So Professor Homer also noted that deterioration in the quality of eggs has become the most substantial obstacle that human fertility faces in more economically developed countries. And so, importantly, there's, a trend of deferring pregnancy until later on in life in like these same parts of the world, right? And so Hayden Homer, Professor Homer, once again, who, by the way, runs a fertility clinic in Brisbane, Australia, so we got some pretty personal experience here. He said, quote, "This is an increasing issue as more women are embarking on pregnancy later on in life. And 1 in 4 Australian women who undergo IVF treatment are aged 40 or older. IVF cannot improve egg quality, so the only alternative for older women at present is to use eggs donated by younger women." And so, to be clear, IVF refers to in vitro fertilization, which is a series of treatments that help to conceive a child. Okay, so let's see if this is showing up. Yeah, okay, great. So, the process involves collecting a bunch of mature eggs from a person's ovaries, which are then fertilized by sperm in a lab. And so, it's quite different from the typical procedure. It's still, the birds and the bees, but there are quite a few more intermediaries involved. And so, including things like treatment with medications to stimulate the ovaries, to promote oocyte maturation, and to regulate egg release, and to, regulate the uterine lining. And so, central to the challenge here is that precursors to eggs are established during the development of females in utero. And so, there isn't an endless supply. There's a finite number of these cells. And so as a result, there are various damaging events that can compromise the integrity of these cells throughout life. And, while successful treatment can repair the majority of these cells, the precursors to the eggs are unfortunately not regenerated. And so, they're particularly vulnerable to age-related damage and disruption. And so on top of that, aging can result in a variety of dysfunctions, right? From genetic to mitochondrial instability. That's just a normal part of aging. So the overall challenge, that was the overall goal that this group was pursuing. And, I noted at least some of the team has a track record of evaluating how a particular biochemical pathway participates in aging. NAD, that early, again, domino in the cascade of other dominoes, is involved in a ton of different pathways, including, metabolism and repair of DNA. And so, importantly, levels of NAD decline as we age, right? This has been shown by multiple groups for a long time. And so, first, this group showed that levels of an NAD-related molecule seems to decline in the precursors to eggs during aging as well. So they also showed that replenishing NAD levels using that precursor, that NMN, nicotinamide mononucleotide, it resulted in improved egg precursor quality and fertility. And so they also found that there may be an important effect of dose of this NAD precursor, and that this is not just like a little bit of something is good, a lot is great kind of situation, right? So there's like a specific amount that would be optimal here. And it's also worth noting that in the text of this study, the authors note that because of the finding that a specific dose range seemed to be relevant here, women who are working on getting pregnant should avoid nicotinamide riboside or nicotinamide mononucleotide, usually called NR or NMN supplements, for the time being. And these are widely available, right? And they're widely marketed for anti-aging effects. And so, they're widely available, easy to get. And in fact, they're among the most popular supplements these days. Every now and then, Amazon doesn't even have any in stock, or any Amazon vendors don't have any in stock because they're so popular. Primarily because of the anti-aging, purported anti-aging benefits that have been described. And so in the study, they assert that they'd expect no major difference between NMN and nicotinamide riboside, that other precursor, when it comes to the effect on fertility that they've identified. And, there's like some pretty good biological logic there, for that assertion. But, I think it's worth noting that there's no demonstrated evidence to support that claim in this study. And there, are potentially some interesting motivations for why they would claim that there's no anticipated distinction, but again, there's just there are no data that support that claim. And regardless of that, the possibilities of this study are pretty interesting and exciting. In terms of what it means for people who are trying to get pregnant, it might mean that using some specific supplements, that they just consume orally, just like you would consume a vitamin, it might improve their ability to get pregnant and reduce the necessity of things like in vitro fertilization. But as always, when it comes to studies like this is a preclinical study, and it needs to be evaluated in humans to verify just how viable a strategy it might be. So I know this is a topic that's probably only interesting to like a specific handful of people on Earth who are either thinking about getting pregnant or have been trying to get pregnant and are starting to consider IVF. But I know it's a concern for a lot of women that I know personally who are around my age. And if there's something as innocuous as supplementing with NMN that could extend their ability to get pregnant without needing anything like in vitro fertilization, any kind of shots, any kind of hormonal treatments, it would be a huge, huge benefit. Okay, that's what I have prepared for you today. Even on top of this story, there's an interesting human brain evolution and lateralization story that I really wanted to engage because it's super interesting. And then there's another study, or I guess, proof of principle study where there is like an infant movement tracking jumpsuit technology that I wanted to discuss because I happen to have a 1+ year old, as you can hear in the background, and watching her trying to navigate like motor learning, and she's like this close to walking. I mean, she can walk, but like she still kind of tends to prefer crawling. And so I'm super interested, and it would be awesome to just like be able to have a bunch of data at my disposal to try and understand like what her motor system is doing, while she's like learning all these things. And it might be beneficial to recognizing some like deficits in motor learning in some infants early on, so that you can intervene potentially. But I'm still working on applying to new jobs, and so hopefully I'll have a bit more time in the not too distant future, because these are both like honestly super cool stories. But okay, let's go ahead and start the live half. Okay. Hello, everyone. My name is Ian McLaughlin, and I have a PhD in neuroscience. I just got it. And I just learned that my degree is in the mail. So pretty soon, maybe I'll put it like up here somewhere, so that your understandable and strategic skepticism might be more easily addressed of my credentials. And you should always be skeptical of somebody online claiming that they have credentials. And so on YouTube, I just talked about this really cool study that potentially has identified an easy way to extend fertility in humans as we age. It's a preclinical study, so it needs to be tested in humans before we jump on board. But it could be like a hugely convenient way to avoid having to do something like IVF, in vitro fertilization. So if you're interested in that, you can just type in. I don't know if you can tell, I have a 1-year-old daughter in the background, and she's rambunctious. And so we'll all be graced with her. And she has this this rapidly expanding vocabulary. Her favorite word right now, I think, is books or book. And so that's not like just somebody else. I'm not like ventriloquizing those noises. That is my daughter. But anyways, you can find the YouTube channel by typing in something like Ian Brain Anthropoid or Ian Anthropoid, and you'll be able to find my channel. Love the plant collection. Yeah, I've been working on it now for a while. It's mostly succulents over here. I don't know if you can see that or tell, but also have an orchid that's been blooming now for a while. What do you think about talking about eugenics? Yeah. Okay, let's get to that. We have a caller, and then I will talk about that after this, I promise. Because it's wild. So Chris, if I'm not mistaken, why don't you let us know where you're calling from and what's on your mind?
Thanks for taking my call from San Francisco today. Appreciate it.
My pleasure.
What's on my mind? Interesting question for a brain scientist to ask. What's on my mind?
Yeah.
I've just started yoga, and I'm curious, can yoga, the mind and the body correlation thingy, scientific plus esoteric, whatever, can the mind with yoga affect body functions? In other words, I have a certain heart situation with AFib, and I notice I can slow things down and calm things down sometimes. Mm-hmm. Can the mind, do you think, with yoga or any other such procedures, help the physical body control its biologics?
Yeah, no, that's a super interesting question. I mean, so let's just expand the scope outside of just yoga. But
yeah.
I'll
hang up to your answer. Thank you.
Yeah. Oh, sure. So let's include everything from yoga to just cardiovascular exercise to meditation, right? So in other words, like behaviors or activities you can engage that might have some effect on like brain health. In your case, you're talking about a cardiovascular phenomenon. I can't say for sure whether or not yoga in particular, can yield any benefits for AFib, specifically. But if we, broaden the scope a little bit more to, anxiety-associated conditions, depression, but then even things like neurodegenerative diseases like, Alzheimer's disease or dementia, there have been some studies that do suggest that engaging in cardiovascular exercise or, exercise of, actually it was specifically cardiovascular exercise, did yield some benefits with regards to the rate of deterioration in dementia and the frequency of dementia. And so this was like, I always forget to check the specifics, but I believe it was like 20 minutes of mild cardiovascular exercise about 3 times a week. And so, yoga, and like I feel like for people who've never tried it, it seems like it's this super duper simple, easy thing to do, and it's not challenging at all. But the reality is, yoga can be extremely challenging, particularly as you get more advanced. And it has a sort of meditative aspect to it, as well as a more physical, just exercise related benefit. And so, yeah, I mean, there's every reason to believe that doing things like yoga or meditation can yield benefits in, brain associated health. And but yeah, I mean, I haven't seen any studies. Maybe they exist. I just haven't seen them that suggest that for AFib in particular, any of these exercises is beneficial beyond any kind of other treatment. But yeah, I mean, there's certainly something there. Okay, so Richard Dawkins. I don't know if any of you use the app Twitter or if you ever frequent it on the internets, but and I don't, if you're unfamiliar with who Richard Dawkins is, he's an extremely famous and extremely influential scientist, evolutionary biologist, and he wrote arguably one of the most important, like, hard science related books for the public, called The Selfish Gene, that influenced generations of scientists. It was a huge influence on me to enter into science, and it also, part of the reason it was so influential is that it talked specifically about evolution by natural selection at a time when there wasn't that much sort of granular communication of what that really means, right? Probably most people's understanding of evolution at the time was limited to like survival of the fittest, and that's just an overly simplistic and reductionist view of what evolution by natural selection really is. But part of why that book was so influential is that it sort of extended the application of evolution by natural selection, and it influenced a lot of people's worldviews. And you can never take that away from him. He's a very, very important person in the history of science, at least in the modern history of science. He's also, a brilliant guy. I think undeniably he's one of the smartest humans, and for many decades. However, in the recent past, and I wish that I had sort of prepared something a little bit more formal so that I could be a little bit more coherent here. But in the recent past, he has engaged topics that are outside the domain of science specifically. Oftentimes these are topics that abut politics and sociology, and I don't begrudge him for doing that, but I think it's clear that in some cases he's engaging topics that aren't under his sort of purview of expertise. So today he put out a tweet, and he does this every now and then. It makes me wonder if he's not being intentionally provocative. But he puts out a tweet where he said that, and I'm just going to paraphrase here. He said that, and it was a tweet about eugenics. Okay. And he said that I am not saying this, I'm quoting him or paraphrasing him. He said that the argument that eugenics doesn't work is absurd, and that it would work. That doesn't mean that we should do it. That was essentially the kind of the concept that he was conveying in tweet form. And understandably and justifiably, he received a massive backlash from, everybody from, people involved in politics to people involved in the humanities and sociology to, hardcore scientists saying, not only is the kind of concept that you're trying to communicate flawed, but also the biology underlying what you're communicating is also flawed. And because it was a tweet, it was a very kind of abbreviated statement, right? That's sort of the limitation of Twitter, right? But the notion that eugenics, if he's just saying that like selective breeding works, then yeah, but it's also like, that's not a particularly like enlightening concept, right? Selective breeding, and he knows, like, we've selectively bred for cows that produce a ton of milk. We've obviously selectively bred wolves into like dogs. And so, yeah, that works. But eugenics goes beyond selective breeding, and it makes the argument that you can create a more perfect human by engaging in sort of population control dynamics. And there's just no evidence that that's true. There's no like instance in human history or natural history where pursuing eugenics has yielded any benefit at all. And very frequently the opposite, right? It doesn't. You don't have to strain too hard to think back to not that long ago when there was a very, very violently motivated movement that was interested in eugenics, in creating the Übermensch. Okay, so there's that. Okay. So yeah, so what do I think about it? I think it was a huge mistake for him to say that, and it was tremendously irresponsible, and also just wrong, which is odd because his expertise, is in evolution, and and to be an expert in evolution, you have to have some kind of proficiency with genetics, and so. Yeah, I mean, part of me just wonders, kind of like one of his sort of compatriots in a lot of these statements, Sam Harris, I think oftentimes, I suspect, and this is pure speculation, I just suspect that they must, in some of these instances, are intentionally being inflammatory to drive attention towards themselves. I could be totally wrong, but if that was his mission accomplished today. And this isn't the first time he said something like this, and it's troubling, and it's kind of depressing also because he's somebody that has influenced, he influenced me considerably, and to hear him make these like odd statements, just it's disappointing. And it's not for any politically motivated reason. I mean, just purely on the science, it's wrong. And that's not the only important criterion by which we ought to evaluate these statements, but it is a very important criterion because he's a scientist. Okay. All right. And I'm sure, I'm happy to talk about that more, if anybody would like. Oh, let's do that. But perhaps that will, I'm trying to get these comments there. There we go. All right. People, he got his brain doctorate from online University of Phoenix for $100. Oh, I wish. Actually, I didn't have to pay any money for my PhD. I was actually paid for my PhD. So you could have done me one better by saying that I didn't even pay for it. But no, is the University of Phoenix still operating? No, I was at the University of Pennsylvania. Yeah, you can check it out online. Soon I'm going to have a little... purportedly, apparently my diploma is in the mail, but they said it can take 3 weeks to be delivered, and it's like I'm literally in the same city as my university. Like, what are they using? The Pony Express or something? Anyways, okay. So, could you speak on escitalopram and the brain? Sure. So escitalopram is an antidepressant in the selective serotonin reuptake inhibiting category of drugs. This is sort of like, as a family of medications, kind of like the frontline treatment for depression and a lot of mood-related psychiatric conditions. It's similar to another. And the trade name for escitalopram is Lexapro. It's a pretty famous medication, widely used. It's actually related to another similar drug called citalopram, which is Celexa, and it's a more potent kind of version of citalopram, if you want to think of it that way. So it has been used to treat depression in adolescents and adults, generalized anxiety disorder in adults, and social anxiety, OCD, panic disorders, a lot of anxiety-associated conditions. So it's Lexapro. That's right. So how do these drugs work? What they do, this is true for Celexa or citalopram, also Prozac or fluoxetine. These are selective serotonin reuptake inhibitors, as I said, and what they essentially do is they extend the amount of time, the length of time that a serotonin molecule can kind of hang out in a synapse, right? A synapse is the point of communication between two different neurons. We have about 86 billion or so neurons. And some of them participate in very specific things. Some of them regulate vision, enable you to see things towards the back of the brain in the occipital lobe. Some of them help you to remember things. like the most notably, perhaps most famously, the hippocampus. Not only the hippocampus, also the neocortex and other brain regions, but those neurons are important for those aspects of our consciousness. Well, some of them also regulate your mood, moment to moment. Like, what is your sort of emotional disposition? And serotonin is not the only neurotransmitter that regulates that, but it is extremely important in regulating mood. And so, therefore, mood-related psychiatric conditions can be influenced by regulating serotonin levels. For a long time, we were operating under a sort of accepted model of the serotonin hypothesis of depression. We now know that the story is more complicated when it comes to depression. It's essentially always going to be more complicated than just one neurotransmitter, but it is without any doubt that serotonin plays a very critical role in regulating mood. So that is like the proximal acute effect of the drug. However, when it comes to all of these drugs, when treating a condition like depression, it takes about 2 to 3 weeks for the therapeutic effect to manifest, which is interesting because these drugs will pretty rapidly increase serotonin concentrations in the brain, indicating that obviously, well, not obviously, but very likely, therefore, depression is influenced by serotonin levels, but the therapeutic effect of these drugs doesn't rely solely upon elevating serotonin levels. Rather, there's some change in the brain that emerges after a while as a function, as a byproduct of these elevated serotonin levels. That we could talk about more if you'd like, but that's the sort of like the introduction to these family of drugs. It's more complicated because everyone lives and experiences are different in many aspects. Oh, and thank you very much for the super heart, Sadie. Yeah, that's true. I mean, there's a reason that mood-related psychiatric conditions are among the hardest things to treat in medicine, because, inevitably, they arise between the brain-environment interaction. It's not solely a function of unique neuronal architecture, unique genetics that you inherited from your parents. They play very, very important roles, but the environment plays an extremely important role as well. And as you indicated, that's absolutely true, that different things can precipitate depression or anxiety disorders. It's not only one thing that must be experienced by everybody who develops depression, right? It can be different among different people. And different people have different vulnerabilities to developing these mood-associated conditions. And that extends beyond just depression, PTSD, and other psychiatric conditions. Okay. Let's see. I've missed a bunch of comments. Yeah, right. Why do people still believe it's the left and right system when it's clear as day both playing us? Oh, I assume you're talking about politics. Couldn't tell you. Yeah. All right. Happy Sunday. Oh, hey, what's up, Abyss? Good to see you. Happy Sunday to you. Why won't Neil deGrasse Tyson debate a knowledgeable, non-spherical, non-rotating Earth believer? I wouldn't be surprised if he probably has engaged flat earthers, at least on the internet. It's just like, I wouldn't debate somebody who makes outrageous claims that are so divorced from scientific reality, because it sort of puts both claims on a sort of similar footing. And that whole concept just has not arrived at a level of scientific scrutiny or evidentiary sort of threshold that it warrants that kind of treatment. His sweater is made out of polyester because he can't afford wool. Well, that's partly true. I mean, I certainly can't afford like very nice sweaters like cashmere and stuff like that. But this is actually cotton, and then it has this other stuff in it too. But yeah, no, that's true. Okay, if SSRI medications are such, what contraindications are there towards the efficacy? Oh, I see, of SSRI. So another okay. So the word contraindication, generally when we're talking about medications, means that is referring to potentially hazardous interactions between different drugs. So, for example, you wouldn't want to combine an SSRI and then a serotonin releasing agent, because you might risk, serotonin toxicity or essentially serotonin syndrome or seizures that come about because of overly high levels of serotonin. But what I think you're bringing up, the topic you're bringing up, I think is like, what evidence is there that these medications are ineffective? Well, first of all, they're not effective for about 30% of people who are being treated for depression and mood-related psychiatric conditions. That's just like one estimate that I've seen, or one evaluation that I've seen. That number could be greater, but the point is that while they're effective for a lot of people, and are sort of extraordinarily useful in treating depression, and that there's still room for improvement. And these drugs are more targeted than alcohol, let's say, right? They don't just like influence every part of the brain like alcohol sort of does. But they're not as targeted as could be. They're not, solely influencing the specific circuits of neurons that are implicated in depression or anxiety. They're just, it's sort of like a sledgehammer rather than, a scalpel, right? I mean, I don't even want to use the word scalpel because that sort of evokes images of surgery, but, it's sort of like casting a net to catch fish versus spearfishing, right? We could develop much more targeted medications to treat these conditions that would theoretically be not as laden with side effects as SSRIs are. SSRIs have a pretty broad profile of side effects that can make them nearly intolerable for some people. They influence everything from appetite, libido. Infamously, people basically oftentimes will just lose their sex drive altogether, and of course that's an important component of life for a lot of people. So that is part of the motivation for why part of the motivation for why a lot of research is trying to arrive at a better, deeper, more granular understanding of what causes depression, and some of the recent advances in developing non-SSRI treatments for depression. So these are, everything from ketamine or S-ketamine to transcranial magnetic stimulation and so on. Okay. Comments on the central lateral thalamus regulating sleep-wake state in anesthetized animals. Oh, I haven't seen it. Central lateral. Oh, wait, did I? No. Oddly, I saw maybe this is the paper you're referring to. Oh, is it the paper you sent me? The argument that a group has found like a sort of like a let's call it like minimum common denominator of consciousness that arises in a specific part of the thalamus. I haven't read that paper thoroughly enough to comment on it. Okay. So I'm trying to come off Suboxone. Is giving you depression withdrawal hopefully don't last long? Yeah. Well, one thing. So for anybody that's not familiar, Suboxone is one of the like main what's called medication-assisted therapies or treatments for opioid addiction. So you're probably more familiar with methadone. Methadone has been around for a very long time, and it's very helpful for people who have been addicted to heroin or oxycodone or fentanyl, unfortunately, because the withdrawal from these drugs is extraordinarily severe. Perhaps the most aversive withdrawal syndrome that you can experience. It's not the most dangerous, though. Withdrawal from alcohol, believe it or not, is more life-threatening. But methadone has some challenges because it's extremely long-lasting, which is a benefit. I mean, so you don't have these peaks and lows of the effects of these medications. But it also, just due to the way that it interacts with the receptors that it binds, these are the same receptors that, oxycodone or, heroin or morphine will bind. Due to the way that methadone interacts with these receptors, it actually can be even harder to quit methadone than other medications or other opioids. Suboxone is an interesting alternative. Suboxone is actually a combination of two drugs. One stimulates opioid receptors, and one actually antagonizes them. And so it basically prevents other opioids from binding the receptor while stimulating the receptor just a bit. And so it can attenuate the severity of withdrawal. And it is becoming a preferred alternative to methadone. And it's extremely beneficial and useful. If your goal is to get off Suboxone, I mean, if I were in your shoes, and I'm not a physician, I'm a scientist, if I were in your shoes, I would make sure that you do it with the assistance of whomever's prescribing the Suboxone, because you don't want to just jump into this, without any kind of like assistance, objective assistance. But your concern, you're experiencing some withdrawal, that's to be expected, unfortunately. And you're absolutely right that it's not going to be forever, and given enough time, that withdrawal will abate. And then the challenge, of course, is always going to be the long-term abstinence. That's actually like the arguably one of the most challenging aspects of recovery from opioid addiction. And thank you so much for the super heart, Sherry. I really appreciate it. Okay. I hear a young and aspiring neuroscientist in the background. Oh no, she, well, right now she has this love for books. She might have just said it. She just graduated from saying "buh" to "book," and she just loves reading. So yeah, we shall see. Hello from Philadelphia. Hello from Philadelphia. I'm in Center City. Okay. Oh, wild. Marijuana and all its properties cures most things. Illegal because pharma companies lose money. So, okay. So that's an interesting topic, right? So first of all, there is enough evidence to suggest that cannabis is useful for the treatment of a bunch of maladies. And it's not really the treatment of the maladies, it's more managing them. And in most cases, in fact, in all cases I've seen in the scientific literature, it's palliative, meaning that it doesn't cure the condition, but it reduces the suffering derived from the condition. So this is like, for example, multiple sclerosis or cancer-associated pain or chemotherapy-associated side effects. There is one case where it does, it's at least as ought to be considered at least as much of a medication as pharmacological medications or let's say pharmaceutical medications, which is for the treatment of seizure disorders, particularly in young people. However, it is not curing any of these conditions. And the problem with making the claim that it can cure all these conditions is that there's no evidence for that. And when, you exaggerate, and just to give you an idea of where I'm coming from, I think we should completely legalize cannabis for recreational use, just like alcohol. So, it doesn't even need to be medicinally legitimate for it to warrant legalization in my mind. Okay. So that's just where I'm coming from. But I think you do that argument a disservice when you say that it can cure cancer, it can cure Parkinson's, it can, cure multiple sclerosis, because it just can't. Well, there's no evidence that it can. And when you make those claims, it's so easy for people who are supportive of prohibition to say, look, they're making these absurd claims and we know they're not true, right? So, the good news is that you have evidence on your side, and you have sort of like logic on your side here, right? If alcohol is going to be legal, cannabis should be legal, because alcohol is responsible for one of the highest rates of preventable death certainly in the United States, but not just in the United States. Tobacco is responsible. It's I think the leading cause of preventable death in the world. Both of those drugs are legal to consume recreationally at your however you'd like. But cannabis, which is not responsible for any kind of severe public health burden, not in the slightest, remains as illegal as a drug can be, at least from the perspective of the federal government here in the United States. And I think that, you don't need to make those claims to argue that it ought to be, legalized. Now, your argument that because it has all these benefits and the pharmaceutical companies can't profit from it, that's why it remains illegal. Well, I would push back on that, because there are pharmaceutical companies that do provide, essentially like extractions of cannabis to treat a variety of conditions, and they profit from it. And so also, cannabis will be extraordinarily profitable. It already is extraordinarily profitable. And so, that's really not how pharmaceutical companies operate. If there is some kind of potential profit motive for them, they will, I assure you, find a way to patent and sell, some kind of cannabis-associated thing, right? Treatment, whatever whatever it might be. I think I'm ODing on this topic. Fair enough. What are some growing areas of neuroscience research? Super awesome. I love that topic. So where others have said we're sort of in a golden age of neuroscience, and I don't know how easy it is to recognize when you're in a golden age, whether or not you're in a golden age, if you know what I mean. I think you have to sort of recognize it in retrospect, because after a golden age, necessarily, there is no longer a golden age, right? And so, right now, neuroscience is one of the most rapidly advancing fields in biomedical science, And that's due to the proliferation of a bunch of different technologies and tools that enable us to answer or ask and potentially answer questions that would have been completely unavailable to neuroscientists even just a few decades ago. I'm talking about like optogenetics, chemogenetics, really interesting, the integration of more sophisticated computational techniques and engineering. And so, like maybe 30 years ago, the notion that we would develop a whole brain-computer interface would seem like complete science fiction, whereas at this point, it's more like, it'll definitely happen. It's just a matter of developing the technologies to enable us to get there. So what are some of the hottest fields within an already rather hot field? One is certainly the relationship between the microbiome and the central nervous system. So the microbiome, probably many of you are familiar, or at least would recognize that term. It refers to all of the different microbial populations that inhabit different compartments of the body, most notably perhaps the gut. Your gut. You can think of your gut as like a coral reef. The coral reef itself is the product of a living organism, but a bunch of other living organisms live there too. And so, the microbes there are sort of like the fish that live in and around a coral reef. And it's without question at this point, a bunch of different interactions between your body and these microbial populations occur that are meaningful for everything from metabolism, the immune system, and higher level, cognitive processes and emotional regulation, psychiatric conditions. And so the difficulty here is that the microbiome and neuroscience, or let's say, molecular biology that is addressing the microbiome, and genetics and neuroscience, these are all interdisciplinary fields. Many scientific disciplines comprise these fields. And, these are some of the hardest questions that biomedical science can confront, like the relationship between the genetic activity of all these microbes in the gut and, the brain, which is in and of itself extremely difficult to interrogate. So microbiome and the central nervous system is one. Neuroengineering is another, where, neuroengineering is a very big field. The integration of technology into, nervous system is one, but then also just developing new technologies that enable scientists to interrogate the brain at a deeper level or a more comprehensive level. There's a reason that, somebody like Elon Musk would found a company called Neuralink and have a bunch of real neuroengineers and neuroscientists on the board, and it doesn't just come across as complete and utter fantasy. It is extremely difficult to complete or to pursue their goal, but it's not complete, fiction here. And so, if you have experience with computer science, computer programming, engineering, and then also neurobiology, there will always be a position for you, at least within our lifetimes. Okay, so that's two. What's another one? Oh, neurogenetics. So just the relationship between genetics within the brain and around the brain and the body. And central nervous system activity, cognition, mood. Because there are so many relationships between the genome, the brain, and then necessarily the environment, there are a lot of questions that remain to be asked. And so those are three fields that I would seriously be considering if I was entering neuroscience today. Okay. Love for books. Awesome. Yeah. We have a ton of books everywhere. So that might be part of it, but I think it's my daughter's unique predisposition. Oh, getting a call. Where do I have that? Okay, now this is coming from YouTube, so it could be a troll. So steel yourselves. All right. Oh, can you hear me?
Yes.
Oh, awesome. Okay, what's your name and where are you calling from?
Samuel, Northern Germany.
Samuel from Germany. Great. What's on your mind?
So I really could not watch the second season of Star Trek Discovery. I couldn't finish it.
Okay.
Like, it was just so bad. It just, like, I gave it a chance, for the first season. But the second season was just, like, terrible.
I have to say, I've never been a huge fan of Star Trek, but, I take your word for it that it's not particularly as compelling. But what brings that up? What brings that to your mind right now?
I don't know. That's just how I feel currently.
Okay. Well, thanks, Samuel. I appreciate the review. Okay. We talk about a lot of things here on the Anthropoid live science chat. Okay. Here we go. Best brain foods. And then, yeah, kratom. Okay. So first of all, when it comes to like brain foods or the relationship between nutrition and really health in general, it is one of the most frustrating sciences. And it's frustrating because it's really difficult to conduct rigorously controlled studies of people's diets and their health outcomes, right? Think about how you would devise like an optimal study. You would have a population of several thousand people who eat only very specific foods, never stray, and then you can follow them for many decades to see if they develop any kind of diseases or ailments. And you just can't do that. So really what we're limited to is using tools like epidemiology, broad population statistics, to see what kind of diseases tend to crop up and where, and what kind of diets those folks tend to consume. And so as a result, there's only really like broad strokes with regards to like foods that are good to avoid and then foods that might be uniquely beneficial. So first of all, there's pretty much no reason to consume simple carbohydrates apart from them being delicious, or unless you're like a high performance athlete. There are several studies that have shown a strong correlation between diets that are high in simple carbohydrates, in other words, sugar, and early onset of dementia and more aggressive onset of dementia. And that's, beyond the like more peripheral, like body associated maladies. So if you were to go to like most, I think, nutrition scientists, most, not all, but most, they would probably recommend a diet that's called, usually referred to as the Mediterranean diet. There are like iterations on the Mediterranean diet that are like the MIND diet. I'm sure people are sick who have heard me talk about this before, probably sick of hearing me talk about it. But basically, these are diets that are sort of unsurprising in their composition. It's green leafy vegetables, seeds, and nuts as snacks, lean protein. The Mediterranean diet calls for a glass of wine every now and then. The MIND diet does not. And there's now evidence to suggest that any consumption of any amount of alcohol is just deleterious. It's not even just benign, it's deleterious. So yeah, you could look up the Mediterranean diet or the MIND diet. The MIND diet is very, very similar to the Mediterranean diet. It just also includes like some like sodium restrictions and stuff like their salt restrictions. There is one like food ingredient that has been sort of consistently highlighted as potentially beneficial, and that's turmeric. Diets that are high in turmeric tend to occur in people who have lower incidences of dementia and sort of brain-related disease. So there's that. So you might consider introducing a little bit of turmeric into your diet if it's not something you regularly consume. But beyond that, I can't tell you that make sure you eat a bunch of avocado, a bunch of coconut oil, and only eat turkey, right? There's just not a lot of evidence to suggest that there's any one specific diet that is beyond doubt more beneficial than any other. Okay. Glass of wine once in a while, turmeric, awesome. Yeah, it tastes nasty. I like turmeric. Coronavirus, dead the people. And then, metformin. And then, kratom. Let's talk about that really quick. So kratom, for anybody that's not familiar, is a tree that grows native to Southeast Asia, but it's now grown many other places, and it just looks like a tree. Like, it doesn't look particularly special. But it is special, because within the leaves of this tree, there are molecules, most notably mitragynine, which is an opioid, meaning that it interacts with, or at least there's a lot of reason to suspect that it interacts with a lot of the same things that opiates like morphine, or oxycodone or so on interact. Oxycodone isn't technically an opiate, but it's derived from opiates. But there's also evidence to suggest that kratom has additional pharmacology on top of its opioid activity. It is habit forming. It's addictive. But there is a lot of anecdotal evidence to suggest that people have used kratom to help wean themselves off of more addictive opioids, more likely more threatening opioids like oxycodone or fentanyl or heroin. These days, most like samples, at least in Philadelphia, of heroin have fentanyl in them. And fentanyl is arguably one of the biggest threats to public health in the country right now. So people have said that they've used kratom to wean themselves off. It's sort of like a medication-assisted treatment for opioid addiction, like methadone or Suboxone. But kratom is far less studied than either methadone or Suboxone or any other opioid. And so as a result, I would always hesitate to suggest that anybody take it, particularly if they're trying to quit, an addictive opioid like heroin or oxycodone, because opioid addiction is no joke. It is, in fact, opioid addiction is one of the leading causes of fatalities in the United States right now. Over, somewhere around the ballpark of 70,000 people have died year over year since like 2017. It's gone down a little bit, but not nearly as much as we would like to see it go down. But this is me on a soapbox right now, I wish that kratom were more widely studied, because this is an unprecedented public health crisis arising from drug use. And I would argue we need every tool we can get. And if kratom has some unique, features to it that distinguish it from methadone and Suboxone, and there are differences between methadone and Suboxone that result in one being preferred over the other in some cases. But if kratom has its own unique features, then hey, maybe that's another tool that we could use to address this unprecedented number of people who are dying every year from drug overdose. Okay. So then coronavirus. Yeah. So I did actually 2 things on YouTube on the coronavirus. It's an odd study, It's a case study in what can happen when an infectious disease arises in one area versus another. And in this case, it arose in Wuhan, in Hubei, China, Hubei province, which is sort of like a kind of hub of transit within China. And so a ton of people go through Wuhan. And as a result, a ton of people have been exposed. And coronavirus is most similar to other similar coronaviruses, notably SARS and MERS, which came up in waves in the sort of early 2000s and then like 2010s. I don't know what the name for those years are, but fortunately we're out of them now. But what's different about this new coronavirus, which now has the name like COVID-19, doesn't quite roll off the tongue like SARS and MERS do, but the WHO made a concerted effort to not name it after a specific country, because you don't want to associate any kind of stigma with that country. But so COVID-19, it has infected way more people than MERS or SARS did within a similar time span. It's also killed way more people. Now that doesn't necessarily, we still don't know a lot about the biology of this virus, not nearly as much as, the other coronaviruses. And so it's unclear as to whether that might be a function of it being more fatal, like just a more dangerous virus, or if it's just that it instead of cropping up in a lesser populated area, because it arose in this highly densely populated area. I think 11 million people live in Wuhan. That's why. And there are a lot of interesting aspects of coronaviruses versus other viruses. And there's some interesting forecasts of like, okay, what can we expect given the numbers that we're seeing now of people infected and the numbers of people who have died? Will this come and go just like the other coronaviruses did, like SARS and MERS? Or is this just going to sort of like enter into the kind of the landscape of viruses that we're, regularly, encountering, just like rhinoviruses that cause, like the cold, or influenza virus, which causes the flu? It's just, it comes in these sort of seasonal waves, just because it has reached a sort of threshold of number of people who've been infected that, it's just always going to be with us, and it'll just sort of follow this seasonal kind of pattern. So if you're interested in that, you can check out my YouTube channel. If you type in like Ian Brain Anthropoid, you'll probably get to it. Did the U.S. make the virus? No. The speculation is that, and it's, informed speculation, is that it likely arose similarly to the way that the other coronaviruses arose, which is zoonotic, meaning that it started in, they suspect bats. What do they call it? It's like a cool kind of bat. It's like like a harpoon bat, or it's something like that. But anyways, bats, and essentially people were exposed to the virus because of this transmission between animal, some other mammal, and food sources. There's also some really interesting, like, sort of geopolitics that has been interesting to read, which is like, because of the tariffs on pork, because the China imported a lot of their pork from the United States, because it became so much more expensive in China, more people likely, went to other alternatives, for protein, being like fish and poultry. And it just happens to be the case that in this part of the country, that those areas just they're not like rigorously hygienic, right? They're called wet markets for a reason. And so as a result, these areas are particularly vulnerable to this kind of an outbreak. And so, it's just like an interesting, and again, I talked about this on the YouTube, but like, it's an interesting kind of intersection of economics, global politics, and biomedical science. We have a caller. Okay. All right, T-Bone. Oh wait, I don't think you've connected yet. Okay, so T-Bone Productions. If you don't mind, what's your name and where are you calling from?
Hey, my name's Tyler. I am over in Fishtown working right now.
Oh, that's awesome. Yeah, so just so everybody knows, Fishtown is part of Philadelphia. It's arguably, I think, one of the coolest parts of Philadelphia. But anyways, yeah, what's on your mind, man?
Let's see. What was I thinking? I was thinking about what your take is on mental exercises. I've seen that there are applications and programs designed to take you through a sequence of usually like things you have to solve. And I was wondering what your take is on those, if you think they're effective or maybe they lose their effectiveness because they don't change up enough.
Right. Yeah. So like one example would be, I think, Lumosity or Luminosity was like was very, very popular, at least a few years ago. So the short answer is there's not a lot of evidence that these platforms deliver any kind of unique benefit as a function of like their unique, procedure. And in fact, at the University of Pennsylvania, in our mutually beloved Philadelphia, there was a group who evaluated whether or not something like luminosity, they didn't name luminosity specifically for obvious reasons, but they were evaluating whether or not they actually do deliver any kind of measurable change in cognition. And in fact, funny enough, the person who was overseeing this study ended up on my thesis committee. But anyways, like the short story is that they expected, their hypothesis was that yes, it would deliver some kind of cognitive benefit, be it improved attention span or these kind of verbal recall, things like that. And they just, they found,
it sounded good.
Yeah. But they were just completely incapable of finding any benefit. So that's the sort of like the proximal short story. But I mean, I don't think it's a stretch for there to be some benefit to, cognitive challenge in general, that, it is beneficial to read, to challenge your mind with, new problems, new issues to solve. And so, it's safe to say that not doing that is detrimental. It's detrimental to, developing dementia, earlier onset of dementia and stuff like that. And so, there's something there, but the argument that luminosity or any of them have any kind of unique value beyond just like doing Sudoku, reading a book, that kind of thing. At least I've never seen any evidence to convince me that it's the case.
Okay. Another thing I was wondering if you have some insight in is I have a form of autism that was formerly known as Asperger's syndrome.
Yeah.
And I do manage to live like a life to an extent that most people don't even realize it unless I mention it.
Huh.
But it is still like problematic and troublesome where I just have days where I just can't even function. But I was wondering if you have any insight or advice as to from your educated knowledge of what I could do to improve life.
Yeah. Well, so as I always like to remind everybody, I'm not a physician, I'm a scientist, and I study mood and addiction, right? So I would hesitate to give you any kind of advice when it comes to that. but here's what I can talk about, at least with some level of competency. So actually, one of the smartest people that I know that I've worked with in neuroscience is he studies autism, but the sort of the genetic underpinnings, the potential genetic underpinnings of autism spectrum disorders. And what's interesting is that it seems to be the case that at least some of the unique brain architecture that arises in autism arises because as we develop, there are certain, we have, my daughter, well, actually not quite yet, I have a 1-year-old, she will have more synapses in her brain for a period of time than we have. And then as she gets older, as we get older, that number of synapses is pruned down, right? You're essentially like boosting signal to noise, theoretically. You're getting rid of the synapses that are not as important, theoretically, in favor of the ones that are more important. And in that process, it's called synaptic pruning, is regulated genetically. And so if you have a slight difference in those little machines that are responsible for doing the pruning, that pruning will produce something unique. And so that is one of the, I think, most compelling concepts or frameworks to understand why it is that in autism spectrum disorders, as you're clearly identifying, it's a broad spectrum. And some folks can function quite highly and oftentimes have some interesting faculties that folks without autism do not have, but some people it's debilitating. And so these slight nuances in how the brain undergoes synaptic pruning may explain part of that. With regards to improving quality of life, honestly, Tyler, I don't have any insights that are worth sharing with you. I'm sorry to say, but as we learn more and more about the sort of the basics of autism spectrum disorders, I'm sure that we will come to a point where you have this unique quirk in this part of your brain that results in heightened anxiety in certain situations, for example, and therefore we have the perfect thing to address that unique feature of your brain. But we're unfortunately not quite there yet. But it is a super interesting field in neuroscience. It's something that I absolutely would have considered going into had it been available to me early on in my academic career.
No, I appreciate your insight. But yeah, you're right. The whole thing is like there's no one answer for a whole group of people. Like we have our meetings actually over by Rittenhouse Square, Ethical Society, and we have a turnout of sometimes up to 20 different people on the spectrum, and just everybody's so vastly different. Somehow like unique in like having the similar diagnosis, but the way it affects us is very, very different.
Yeah. I mean, and that's unsurprising, right? And I wouldn't be surprised if, as we come to a more complete neurogenetics, we will probably be able to parse some of these slight nuances amidst the spectrum. And, as a result, we'll be able to, it won't just be this blanket thing. You have this specific form. You have this, unique aspect to your brain that is consistent across other people who also have this unique aspect that's not shared by everybody who's on the spectrum. But yeah, man. Listen, I appreciate you sharing. I actually didn't know that those meetings were occurring. The Ethical Society here in Rittenhouse Square. This is for other folks. It has some of the coolest events, and it's in one of the most beautiful parts of the city. So if you're ever around, you should check the events that are happening there. But yeah, man, I wish I had better insights for you, more useful insights for you. But at least at this point, we'll have to watch this space.
That's okay. Are you familiar with the savant syndrome?
Moderately. I haven't seen any kind of like rigorous scientific explanations for why it is that folks can develop these remarkable superpowers essentially when it comes to certain activities. But beyond just that being the case, I don't know about the neurobiology there.
Yeah, I find that like really interesting. It's like how did this just sort of magically develop in an individual where they have this particular skill they happen to develop and sort of seem to have a natural instinct for it, but I guess that wouldn't make sense to call it a natural instinct because it's not something we've developed as a race. That, as far as I've seen, I don't know.
Yeah, I mean, you know, that's part of why it's so interesting.
Like
That
a roll of the dice.
yeah, sort of, but that, like, savant syndrome like capabilities can arise from an injury in some cases, where all of a sudden somebody develops remarkably accurate memory, being able to remember like just the subtlest details of a visual scene, or like remarkable capabilities with computation, like being able to just perform these calculations just off the top of their head. That would, it would take me another 7 years to figure out how they do it. But yeah, it's interesting. It's something that I plan on reading a bit more about. So thanks for bringing it up. But listen, Tyler, thanks for calling in, man. And I hope to talk to you again.
Yeah, likewise. Thank you.
All right, it's Fishtown, by the way. If you're not familiar with Philadelphia, Fishtown is a very cool part of the city. It sort of has this kind of relationship with Center City, which is more the area that I live in, sort of like Brooklyn to Manhattan. It's kind of like that relationship, but of course, nothing is on the scale of New York, right? Hi from the UK. My wife had an empty cella. What follow-up does she need? I'm not quite sure what that means. I'm sorry to say. Bonsoir, Bernard. Okay, it's almost crazy. I'm so intrigued. All the vaccines kids have to have now, it's obviously connected to Asperger's and autism. So, the short response that I think any scientist or physician who still has his or her license would have to that is there just is no evidence that they're connected. And contrary to I think what a lot of folks claim, this question has been asked rigorously by people who are not associated with the pharmaceutical industry, who have no personal stake in the matter. They're just pursuing knowledge. Like me, for example. Like, I haven't done these experiments, but there is no profit motive in the science that I conduct. It is purely just, and my career incentives are such that, if I discover something new, that is the profit. And I do not get rewarded monetarily or financially by this, apart from I get more jobs by just making new discoveries. So these are the kinds of people that have conducted these studies, these big statistical evaluations, and there's just no significant correlation there. And so here's where I do have some empathy for folks who are concerned about any potential role that vaccines might play in these conditions. So I have a 1-year-old. She's almost a year and 2 months. And, she got all of her vaccines. And it is like a kind of a very dramatic experience to have your little baby get injections, right? It's like I spend, 99% of the day trying to keep her away from sharp things. And of course it's painful, right? And saying, one of the worst things that a parent can experience is seeing their child in pain. So it's this very aversive experience, right? Now, of course, as a scientist, my wife also has a background in science. We logically know that, getting these vaccines is like one of the primary benefits of living in modern society, right? I don't have to be worried that my daughter's going to get polio. I don't have to be worried that my daughter's going to get measles. And that just has not been the case historically, in the United States or in the world. It's still not the case in some parts of the world, right? And so because I don't have a great answer for what specifically causes autism or, the more debilitating, points along the spectrum of autism spectrum disorder, that is unsatisfying to a parent, right? Because you want to know the answer. You want to know, why is my child so unique? And when somebody like me, who I feel like it would be irresponsible to suggest, we know specifically, rather than, drawing information from somebody like that, who's delivering unsatisfying nutrition, right? There are people who will say, we actually do know why your child is unique, and it's not your fault. And, it's never your fault, by the way. And also, by the way, the goal is not to cure autism. It is to help people who are on the spectrum to live a higher quality of life and exploit the unique aspects of their brain. And, so that's the goal. But anyways, when you have somebody telling, providing a very simple explanation for why you have this unique experience. And not only that, but they also identify a villain.
that is extraordinarily seductive to a parent. And I know because I am a new parent. If something bad happened to my child, I would want to know, A, what it was, what the damage was, and B, who did it? And, unfortunately, in this instance, there's just no evidence to support the claims that these people make. Now, if I were concerned about what different things in the environment might do to my child, there are some baddies out there, right? You don't have to only, refer to this one specific, putative potential cause. We know that, there is evidence that exposure to high levels of airborne pollution correlates with increased rates of autism. That has been proven in China. That's been proven, in Shanghai. It's been proven in Mexico. It's been proven in, I believe, Spain and in the United States. Airborne pollution. And it's specifically like what's called PM 2.5 and lower, meaning really, really small particle size air pollution. And then, of course, there are things like, elevated levels of lead in the water. That doesn't result in autism, don't get me wrong, but it is, it can produce negative outcomes. And, even arguably even worse, because it's irreparable, right? This lead never leaves the body, the brain. And particularly when a child is exposed while their brain is developing, it can change the trajectory of their brain development forever and never be able to be solved. And there's no good reason that lead ought to be in anybody's water, but it is in many municipalities. No, not many, but in too many municipalities, right? Flint, Michigan is sort of like the most famous case, which is just unforgivable what happened there. And, I think we as fellow Americans ought to be doing more to help this community recuperate. But Flint, Michigan is not the only city where this is an issue. There's also, evidence of other pollutants that are present in municipal water sources. I did a recent thing on YouTube about this study that came out that identified high levels of basically the chemicals that are either used to create or are themselves like Teflon or like fire retardants. These are remarkably stable chemicals, meaning they just do not deteriorate very meaningfully, and they accumulate in the body. And so, there are some issues with that study that I talked about on the YouTube. If you're interested, type in Ian Anthropoid Brain and you'll get to my channel. But those are things that scientists are on your side, public health experts are on your side, and produce anticipated undesirable health outcomes. The anti-vax movement is not based on any rigorous science. And it is in fact based on debunked claims. So I know I went quite long on that. I didn't mean to, but it's something I've been thinking about just because of my experiences as a new parent, and I can sort of put myself in the position of somebody who is a parent who's trying to understand what happened. All right. Okay. Oh my God, it's Cowboy. More likely you'll have to take them for the rest of your life, huh? Kicking off the first job. What's the phone number then? You can, if you're on Periscope, you can just call through the app. So here we go. I'm not sure that I want to. Forgive me if I'm wrong, but your handle and your profile picture suggests to me that you are not interested in having a rational conversation. And forgive me if I'm wrong about that. Oi, Brainiac. Oi. Hello. Brooklyn and Shaw. Oh, thank you very much. I love these plants too. This orchid, by the way, I've had this orchid for about 7 years. It was the first plant I bought when I moved here. And it's the one that I had other ones and they all put out their terminal spike and passed away. But this one has been blooming every winter, every year, almost like clockwork. And what's interesting about it though, is that, it's really big. I've been needing to transplant it for so long, but I just never got around to it. You can sort of see all the aerial roots. But it's so top heavy and it has such a bad base that I actually use a meteorite. I can actually show it to you. Let's see if it'll. Yeah, you can see it's tipping over. But anyways, this is the meteorite to counterbalance it. And I have to wonder if the presence of the meteorite is somehow beneficial for the plant, because I don't know what the meteorite's made out of. Nickel, I guess, nickel and iron. But yeah, it's just an interesting little quirk that I've been thinking about. All right, it's a fascinating subject area. I agree. We'll call in to discuss the Drosophila brain mapping paper if you've read it. I'm not sure which one you're referring to. Oh, did you get around to reading the comments? I apologize for calling you a fanny face. I don't mind. I am a bit of a fanny face. Okay, can you explain how people can hallucinate specific things like dogs because of brain disease? So, ew, yuck, that's a great handle. I guess I'm not quite sure specifically to what you're referring, that, there's like a specific, disorder that results in a consistent hallucination, like I consistently see dogs that aren't there. There are, however, conditions where people do have visual hallucinations. I mean, most notably schizophrenia. Visual hallucinations are far less common than auditory hallucinations, interestingly enough, meaning, people will tend to hear auditory stimulation like whispers, or, it doesn't even have to be verbal, but, just like these sort of subtle things that they're registering that aren't being done, that aren't in their environment. That is, so there are some consistencies there, but I'm not familiar with any disorders where it's like people specifically always hear elephants, right? But then, of course, there are different drugs that can induce hallucinations, most perhaps famously the psychedelic hallucinogens, LSD, psilocybin. And by the way, like I talk about this so much, but it's such a fun book. There's a book called, I still have these pictures up. This is dumb. Okay, so I put it up on the YouTube. It's called Poisoner in Chief. It's about a guy named Sidney Gottlieb at the CIA who was responsible for like MK Ultra, Project Midnight Climax, Project, what is it? Not Avocado. Project, what are those things called? Artichoke. A bunch of these like really insane, projects that emerged from the intelligence community at the time. And this was like under, Dulles when he was directing the CIA and so on. It's just like this really, really interesting history of the intersection between government, the intelligence community, meaning like the CIA, FBI, and so on, and, society and drugs, specifically drugs. So if you're interested in a book or you want to get somebody a gift, check out Poison. Oh, and it's written by essentially a professor of journalism. He was a former journalist, and now he's, I think, a professor of history, maybe, or journalism at Brown University. Check it out, Poisoner in Chief. I have the cover of it on my YouTube live stream right now if you're interested. Okay. Hello, I come from France. Hello, I come from Philadelphia, the United States. Okay. Let's see. Can you explain? Oh, wait, okay. I just saw that. Flowers are passing away. They have a soul. They are living things after all. Do they have a soul? I am no expert in, theology or spirituality. So far be it from me to deny this gorgeous, living thing from having a soul. But I am more concerned mostly with its water schedule. Thoughts on psilocybin? I have thoughts on psilocybin, although I'm not currently on psilocybin, so I have thoughts about psilocybin. Not currently, though. So psilocybin, for anybody who's not familiar, is like the active ingredient of magic mushrooms. It's perhaps one of the most well-studied psychedelic hallucinogen, perhaps second only to LSD. No, maybe it's actually more studied than LSD. Psilocybin, the molecule, is quite similar to a neurotransmitter with which you're probably familiar, serotonin. And because of that similarity, psilocybin is able to influence a lot of the different brain regions that are regulated by serotonin, including vision, mood, cognition, memory, libido, appetite, a bunch of these different things. And because serotonin is such a complicated signaling system, it's so diverse in its targets. A lot of, the way the brain is handling information is just in a different state. And it does a lot of different things. But one of the most interesting studies recently, at least interesting to me, was that they basically gave a group of people, I believe it was psilocybin, it might have been LSD, but I'm pretty sure it was psilocybin, and then put them in an fMRI, which is super cool. I would love to have been there for that study because, man, I don't know how they got approval for that because it's really hard to study these drugs. They're as illegal as drugs can be in the United States. But basically what they showed was that the sort of what's called functional connectivity, meaning how much when one brain region is active, another brain region is active. That usually means that they're interacting with one another in some way, in some way. And it turned out that the functional connectivity, basically the entire brain and the occipital lobe was heightened. and and so as a result, the sort of the interpretation, the extrapolation of that would be, therefore, visual processing is influencing a much wider swath of cognitive activity. And perhaps that explains at least why one part of the profile of effects of these drugs is sort of transient synesthesia, where you're sort of tasting things that you are seeing, or you're feeling things that you're seeing without actually touching them. But perhaps most practically, psilocybin has been evaluated for the treatment of certain forms of depression, particularly those that arise during terminal sort of cancer, where people are sort of coming to terms with their, passing, their soon to be passing. And it has been shown to be pretty effective for that. I think it's also, I get these confused sometimes, but I think that it's also being evaluated for the treatment of alcoholism. But I might be wrong about that. A lot of these studies are coming out of the NYU medical school, NYU Langone Medical School, I think it's what it's called. But yeah, I mean, I think, apart from, just them being this really unique tool to learn about how the brain operates at baseline, we've learned a ton about the brain through studying drugs, through studying, for example, opioids, right? There's a reason that the mu opioid receptor is named after opioids, and it's because we found that, this is the reason that morphine kills pain, right? We learned a lot about the cholinergic system, or the acetylcholine system, and memory and learning and mood through studying nicotine. The same goes for dopamine, reward, anticipation of reward, attention, through studying cocaine, and addiction through studying cocaine and amphetamine. And so we can learn a ton. And none of those drugs really influence sensory processing in the same way that psychedelics do. Psychedelics have this really, really unique effects profile. And so if we study how those drugs affect the brain, then we can learn more about how these different, signaling systems operate. But even apart from that, they have this potential clinical utility that is now being more broadly established. Hello, Brennan. Some of the best albums were made whilst on drugs. That is undeniably true, for sure. And not only albums from the 60s. Have you ever done the Myers-Briggs test? Yes, I have. I think it's the Myers-Briggs test, right? So the Myers-Briggs test is an interesting sort of fun tool, but much like, sort of like the IQ test, although the IQ test is arguably more legitimate than the Myers-Briggs test, it has taken on this very disproportionate relevance societally. And, it was based on, first of all, it was not devised by like a scientist or a physician. Second of all, it's sort of based on this notion that like human personality, human intelligence, really, can be reduced to, a few discrete variables. And I can't off the top of my mind remember all of them, but it was like 4 of them, I think. The Myers-Briggs test has been used to, evaluate potential company hires. I think my dad had to take a Myers-Briggs test. I've taken it. Actually, I would be interested to know what you think I am. I heard Myers-Briggs described as astrology for HR. Yeah, that's not bad. I mean, in its defense, like it's certainly quantifying some aspect of human behavior, right? And that's interesting. It's fun, and but yeah, it definitely should not be used as conceived of as being this like objective and scrupulous assessment of human behavior. Shane, good questions. Got unanswered. Oh, I'm sorry. Let's see. ENSJ, no. Oh, wait. No, yeah. So I think an INTJ or an ENTJ is what I get. I bounce between those two. Okay. Because if I go on my own experience, it looks like consciousness is the only truth. There is who was it? I'm trying to remember the neurophilosopher who says like, if you have to assume at least one thing, it is that your consciousness is real. Everything else depends upon that. So there's something to that. Some say LSD opens up your third eye of consciousness. So, I've definitely heard that many times. I've heard that particularly associated with dimethyltryptamine or DMT. And the reality is, like, I don't really know what people mean when they say third eye. I think a lot of people refer to the third eye as the pineal gland or the pineal body. The pineal body is this tiny, tiny little nugget in the brain that is responsible for a few things, but it's certainly not the most important part of the brain. If you didn't have a pineal gland, your life would be worse, but you would still be fine. Like, you'd still live, survive. You would have a very difficult time determining when to be tired. But hey, I suffer from that already. So, like, there have been studies where when the pineal body or the pineal gland is lesioned, then you have this sort of circadian drift, as opposed to, like, you get tired when the sun goes down, you get energy when the sun comes up. Rather the circadian rhythm just sort of like drifts, so you get tired later and later, and so on. So I think what people are referring to when they say third eye, I think they're kind of referring to a kind of like a repertoire of experiences or perceptions that seem transcendent and like numinous, and so like feeling connectivity or oneness with the universe, or having these emotional experiences of the experiences of others, feeling brotherhood or fraternity with all of humankind. Like, so can these drugs amplify those experiences? Yeah, for sure. But that doesn't necessarily mean, that they're particularly like special with regards to pharmacology, nor that you're tapping into one specific part of the brain to induce these realizations or these experiences. Rather, it's just that these drugs are modifying your state of consciousness, amplifying the activity in certain parts of the brain that are associated with empathy and emotion. Okay, let's see. I'm sorry if I've missed some of these questions. So can you tell me about your view on making someone's brain more acidic to preserve autoregulation? I don't really know to what that's referring. So I've definitely seen a lot of claims where, like, it's better to have your body be alkaline, or to have your body be like, I almost only ever see alkaline. So here's the reality. Like, your body pH is rigorously regulated, and particularly in the brain. Like, there can be local deviations in pH, in acidity versus alkalinity, but that they're transient, because if they're long lasting, if your brain is just more acidic in general, a ton of chemical reactions that are necessary to occur for you to survive will be disrupted. And so the idea that, like, if you're going to drink water that's alkaline, then you will have some kind of benefit. No, your body will just respond in such a way as to counter that alkalinity. So that's just not like it's a meaningless claim, really, that seems to arise from, broadly speaking, the supplement industry or the sort of supplement adjacent industries. Okay. So I work on the heart-lung machine, and we tend to keep CO2 higher to preserve the brain. I'm not quite sure what that means. On the heart-lung machine, tend to keep CO2 higher. I guess I'm not quite sure why you would ever want to expose somebody to high levels of CO2. Yeah. So, I'm not quite sure about that. I mean, listen, maybe there's something there. I could very well just be ignorant of this particular thing, but, like, for maybe in, like, a surgical setting or something like that, I could imagine you wanting to tweak levels of different dissolved gases, but, like, you wouldn't. She's so close to saying good, but for, like, most people in your day-to-day life, you would not want to engage changing alkalinity and acidity as, like, a health concern. Rather, you should focus, on getting enough sleep, getting some exercise, avoiding simple carbohydrates, eating a reasonably competent diet. Like, those are the things that'll really yield benefits, and just trying to, like, make your blood more alkaline or acidic. First of all, whatever you do is almost certain to be ineffective, but also, it's just going to be a waste of your energy. We are trying to guess your astrological sign. Please put us out of our misery. Well, you can see when I'm born. I can't remember if it changed, but and it's not something I follow to be totally honest. But I was born on January 5th. So I remember there was like a changeover that happened in some way that I just taught, I just didn't understand it. And it's just not something I've ever followed very closely. But yeah, January 5th. Oh, okay. Can't miss this opportunity. So my daughter also calls frogs like gaga, which is pretty cute. Abyss, I will let you keep your name anonymous, but would you mind telling us around where you're calling?
Yeah, so right now I'm living in Tennessee.
Oh.
So I used to live in Pittsburgh. Yeah, if you know.
Yeah, awesome. Okay, so Abyss
Yeah.
from Tennessee. What's on your mind, man?
Yeah, so I just wanted to add up on the questions been asked about the cerebral autoregulation. So basically, the study kind of suggests that the sort of the glial pathway actually kind of affects how the cerebral vasculature kind of dilates and constricts. So there's some potential where you can have, carbon dioxide can have sort of an inadvertent effect on causing vasodilation, because this has been seen in patients with sickle cell disease, where you have, because there's no constant blood supply to the brain, so the brain tried to, compensate the blood flow by causing vasodilation, and that can be detected when there's buildup in carbon dioxide. So I think that's kind of an ongoing research. But yes, I just wanted to add up on that.
I appreciate it, man. I mean, that certainly makes sense, right? I mean, and like somebody was interested in, hot areas of neuroscience, glial biology is going to be an expanding subdiscipline. So that's interesting. Yeah, I've certainly never seen that.
Yeah, so I guess also, like, I asked you if you read through the fruit fly brain mapping paper. That will be I was actually referring to the Google paper. I don't know if you noticed.
No.
So they did sort of like brain mapping for fruit fly. I think the majority of the study was done in Howard Hughes Medical Institute. So I guess, like, what I wanted to ask you is that I don't know if it's like that they used a very fine slicing, which is about 3 micrometers, and they did some novel technique to kind of reconstruct the connectomes, where they kind of collaborated with Google. They had their own deep learning techniques to kind of reconstruct the brain. So I was wondering if you read through that. I think it would be something that might interest you.
I haven't read through it, no, but yeah, that's 3 micron slices. That's like very thin.
I know.
That's pretty cool. That's pretty impressive. Yeah, just to give everybody an idea, so oftentimes, when you're looking at brain tissue on a microscope, you're taking slices of the brain. And, I work with slices that tend to be rather on the thin side, usually around 10 microns. And it's a huge pain in the butt. And, but fruit flies, like the tissue must be so tiny that's pretty impressive.
Yeah. I mean, that's the first thing that really struck me when I first went through the paper, and also the way they did the reconstructions. That they basically employed, like I said, a deep learning technique, and more specifically something called the generative adversarial network, where they kind of train the image and then kind of reconstruct it, or like have some kind of middle compression, and the ladder network tries to kind of falsify the image that's been generated in the middle layer. I don't know, like, as if this is kind of an interesting technique, but I thought that would be one of the novelties of the study, besides the kind of the fine slicing and the whole electrophysiology nightmare.
Yeah. That's interesting.
Thin slice.
It's almost like a software A team, B team, or like red team, blue team, where they're like competing with one another. That's pretty cool. I'll check it out.
All right, cool.
Well, thanks for calling in, man.
No problem.
Always a pleasure.
Bye.
Abyss, everybody. Let's see. Oh man. Okay. I have to say, of like all the people, people in my lab and so on, we send each other papers. Abyss has sent me some of the most interesting papers, and oftentimes they're like well outside of my own discipline, which is probably why, because you get a little sick of reading about only your discipline. But yeah, that has been a very profitable relationship there for me. Oh man, I wish I spoke Arabic. I think it's like the most beautiful written language, and I'm sure you're like making fun of me. But no, let's see, superhuman baby. If I was president, I'd put people who believe in star signs in. Well, we actually had a president who I think was had like an in-house astrologer, I believe. I think Ronald Reagan, or maybe his wife, Nancy Reagan, did have like a consulting astrologer. I'm almost sure. So yeah, you'd have to have a pretty powerful, at least contingent of people supporting you. Happy belated birthday! Oh, thank you very much. Okay, how much has pseudoscience crept into your work? Are there recent discoveries that were once crazy? That's a super interesting topic. How much does pseudoscience? So, I mean, of course, the sort of driving effort is to be as scrupulous as possible, and base all of your future questions on previous data, right? And so you're forming hypotheses, but you're sort of best served forming those hypotheses, being informed by past research. So I mean, let's say pseudoscience. Okay. I think what's considered to be pseudoscience and, let's say, accepted science evolves over time. And I think oftentimes at least, it's a function of like political belief or let's just say worldview that will predispose somebody to, engaging in pseudoscience. But like, as more information comes to light, then the distinctions between pseudoscience and let's say authentic science are revealed. But like some of the most important scientists in history dabbled in pseudoscience. I think like Isaac Newton, one of literally the most important scientists in the history of humanity, also dabbled in alchemy. There's a bunch of these sort of examples of like these brilliant scientists who were vulnerable to being taken by pseudoscience. And I guess maybe like one kind of tangentially related example would be that concepts of addiction have evolved a lot over time. So and we're sort of in the process of watching them evolve, but like for a very, very long time, up until pretty recently, addiction was considered to be just a moral failure, a moral weakness. That the only way that you can fall victim to addiction is if you have like a moral weakness. And I think it was Alan Leshner, I believe, who was a director of NIDA, sort of explicitly articulated like, no, that is not how we think about addiction as scientists and physicians. Rather, it is the brain disease model of addiction that sort of prevails in at least the National Institute of Drug Abuse, NIDA. Now, it's still contentious. There are some scientists who argue it's not really a disease, and there are some problems associated with calling it a disease. But, apart from that sort of semantic debate, it probably would have been considered pseudoscience many decades ago to argue like, no, it's not just like this person is morally weak, and that's why they are, have this chemical dependency and this addiction. Rather, it is just a unique combination of nature and nurture, a unique combination of exposure to environmental stimuli like being traumatized, or just being exposed to addictive drugs, and a unique genetics and neurobiology that, when coupled, produce, addictive behavior. And so, that argument probably would have seemed like pseudoscience back in the day. And now it's certainly not. I'm trying to think of other ones. I mean, well, here's a great example. So, we talk a lot about drugs on this channel, but in particular, we talk about psychedelics quite a bit. And that's understandable because psychedelics are a very interesting family of drugs. But there is a ton of pseudoscience that sort of envelops psychedelics. And it makes one wonder if there might be just some unique aspect of the pharmacology of psychedelics that renders them more likely to be associated with pseudoscience. But the pseudoscience to which I'm referring is that they open up your mind. They open the third eye, or that they enable you to visit other dimensions, or that they enable you to see the real world as it really is, objectively, rather than our own fettered consciousness. And that that there's just no actual rigorous science upon which those comments are based, those claims are based, and so insofar as I engage those topics, that is probably the most explicit pseudoscience that I tend to encounter. Another, of course, is the whole why do we only use 10% of our brain, which might be true for some people, but I kid. It's just not true. It's a myth, and it's just based on a complete misunderstanding of how the brain works and human consciousness and the relationship between brain activity and intelligence and performance and stuff. So that's another instance of pseudoscience. Okay. Sorry, geez, I know I'm missing a lot. Can you please answer my question above with regards to recreational drugs? So you are Brian Fahir. Let's see if I can find your comment. Brian Fahir. The classic once what's considered pseudoscience has to be the earth is round. Oh my God. Okay. Can taking recreational drugs such as MDMA, cocaine increase intelligence while high? Why did Freud, and etc.? Super interesting topic. Well, one of the first obstacles in the way of having an amusing conversation about this topic is that it's difficult to articulate exactly what we mean when we say human intelligence. Do we mean your ability to just write a lot of stuff, or do we mean your ability to focus on a task for an extended period of time? These are aspects of intelligence, undoubtedly, but they are not the end-all be-all of intelligence, right? You wouldn't just consider somebody who writes a lot of words, regardless of accuracy, intelligent. So cocaine, amphetamine, those drugs will definitely enhance your ability to verbalize. There is evidence that in the short term, for example, amphetamine has been shown to expedite language acquisition. I think I might have just been one paper, but so if you consider that to be intelligence, acutely there's some performance enhancement there. Freud wasn't the only bearded man of the history of science and psychology who used cocaine. In fact, you might be familiar with Johns Hopkins University, one of the best medical institutions in the world, one of the most important. It was founded by the 4 founding fathers of Johns Hopkins, one of whom was a notorious cocaine addict, and also ended up being an opioid addict because, hey, the best treatment for cocaine addiction at the time was heroin. That's pretty accurate, actually. At least an accurate depiction of what happened back then. Not that heroin's a good treatment for cocaine addiction. But of course I'm forgetting his name. And actually the TV show The Nick, if you've never seen it, check it out. It's one of my favorite shows of all time. Is sort of loosely Clive Owen's character is loosely based on this scientist. Scientist physician, right? And he was also the source of some of the most important innovations in medicine, like using gloves and stuff like that, anesthesia. He's undoubtedly a brilliant guy, and he used cocaine. But I would submit to you that I don't think it was the cocaine that was responsible for the production of these insights. Rather, it was this person and the things to which he was exposed, and cocaine just happened to be one of them. But the counterfactual is impossible. We don't have an example of somebody like him in his situation not using cocaine to compare him to, right? Clive Owen, right? Isn't it Clive? That's his name, right? Gosh, Bundys are pretty up there with the Astors. Oh, here we go. There's somebody calling in. So I believe your name is Yami Yani. If that's your name, where are you calling from? Or what's your name and where are you calling from?
Yes! Oh my God. I'm calling from Georgia.
Oh, from Georgia. And what's your name?
Naya.
Naya, from Georgia. What's on your mind?
What is the connection between brain accidents and personality?
Okay. Interesting topic. So brain accidents, I'm assuming you mean like traumatic brain injury, like a concussion or, some kind of injury to the head. Well, the short story is that there is a very close connection there. And it's actually a relationship that has been established in neuroscience for decades at this point. Probably one of the most famous cases of a brain injury and a change in personality is Phineas Gage. I believe at this point, to get a PhD in neuroscience, you have to get Phineas Gage tattooed on your brain because every student learns about his case. The short story is that he was, I think, a foreman who was working on a railroad, and at the time they used these iron rods that they hammered in, and they used gunpowder. Gunpowder was involved, and almost never does this happen, but there was a spark, and it shot this iron rod right through his left frontal lobe. And
that stayed on my mind ever since I first heard that story. I have no idea why. It's like everything changed about him. Why?
That's right. Well, so here's why. So, the human brain is remarkably complicated, but it's quite similar to the brain of other primates like chimpanzees or orangutans. And we're genetically very, very similar to these other primates. But what's different about the human brain is this very swollen frontal lobe and this very large neocortex, but in particular the frontal lobe. And so, a lot of the same brain regions that underlie, your sort of primal urges, aggression, libido, appetite, mood, like sadness or excitement or love, these types of things. These brain regions are largely shared with other primates, but it is the evolution of this frontal lobe that enables, which is very, very connected with the rest of the brain. It receives information from all parts of the brain. It can then inhibit those more primitive, more like primal parts of the brain. Some people might call it the lizard brain, but it's really just an evolutionarily more ancient part of the brain. The prefrontal cortex can inhibit those urges given, as a function of its being receptive to your memories of past experience, your ability to forecast future events, cause and effect type of concerns, and, your ability to inhibit reward in search for greater reward later. In other words, doing the hard thing because it'll be better for you in the long run. And so when you have damage to that part of the brain, all of those capacities are compromised. And as a result, people's personalities, things like how likely are you to engage in risky sexual behavior? How likely are you to consume risky amounts of a drug like alcohol? That the prefrontal cortex plays a very pivotal role in navigating those decisions. And so when it's damaged either by a gigantic iron rod going right through it or by just a head injury in a car accident or playing football or whatever it might be, once the neurons in that brain region are compromised, all of those capacities change, and that manifests as riskier behavior, more aggressive behavior, predispositions to drug addiction, and these types of things, behavioral impulse control problems. And so that's the relationship there, at least in this specific case. But, the prefrontal cortex is just one part of it. It's a very important part of the brain, one part of the brain. Other regions are also involved in, aggression, memory, and mood. And so, when you physically change any part of the brain, you're inevitably influencing how signals between neurons are transmitted and handled.
Oh my God.
Yeah. So that, the relationship is one-to-one, right? Brain architecture is, is like directly regulating, or it directly is influenced by, or influences the signaling between neurons. But yes, so that's relationship. What brought this up for you?
I had a friend who got into an accident and he just changed.
What?
Everything about him just changed. I don't know what happened. Something happened to his brain. They said something, I don't know, so something happened and he just changed completely. He wasn't the same person. He used to be just very outgoing. Now he's very introverted. He doesn't talk much. He just looks at me whenever I talk to him. Like he's normal, he talks and he does everything, but he's not the same how he used to be. Everything about him just changed, like right after the accident, right after he got out the hospital. I'm like, what the hell?
Yeah.
What the hell?
Yeah. I mean, it's tragic. I'm sorry to hear that. It was a car accident, I assume?
Yeah, he actually fell out of the car.
Ooh.
Yeah, out of the car.
Jeez.
And something happened to his brain. But the interesting thing about it was he wasn't the that much damage to him. That much damage wasn't that much to his face, anything. It's just his brain. I'm like, what? Doesn't make any sense.
I know. It's like almost eerie, right? And it's like the brain is, I think it's pretty safe to say the most important organ. Maybe the heart could be a contestant, but yeah, that's the problem, is that not only like is the damage to the brain basically invisible, but you can't even feel it because there's no like pain receptors within the brain. So like it is almost like a specter and it only is detectable in the things that the brain regulates, which just happens to be your personality, your behavior, your decision making, all these things. So yeah, I'm really sorry to hear that. I hope that your friend has at least some physicians that he can consult with who will help him, recover from the accident.
Okay, well, thank you for asking my question. Thank you.
It was my pleasure. Thanks for calling in. Okay, where are we? Who am I? What's happening? All right, I should probably call it a night. Talk about adrenochrome. Oh, we cannot talk about adrenochrome. We're not allowed to. I mean, that was the latest rule that came out of the meetings at the top of the Empire State Building. Not allowed to talk about adrenochrome. Otherwise, they'll take me out. So that's a very significant wink right there. Yeah, that is what you call pseudoscience. Anyways, yeah, so I got to go. So I have a podcast called Wired to be Weird. Talk about things like, drug effects, dreaming, Alzheimer's disease, déjà vu, and the life extension claims that have been made recently, and Neuralink and whole brain computer interfaces. You can check it out, Wired to be Weird. I also have a YouTube channel that's very, very slowly developing. But on YouTube, before I go live here, I always do about a 15 to 20 minute coverage of a specific story. And this time it was about a study that just came out that suggests it might be possible to help sustain the fertility of women as they get older without having to do stuff like in vitro fertilization, IVF, or hormonal treatments, or things that are just rather unpleasant that I'm sure most women would prefer to avoid if possible by just taking a supplement. So you can find it by like Ian Brain Anthropoid or something like that. And I have a Patreon, and if you're in a position to be able to help support the various little gizmos and gadgets that I use to communicate science, I would deeply appreciate it. It's patreon.com/anthropoid, and I would be happy to set up a more like one-on-one conversation where you can give me input, or we can talk about specific topics that interest you. So patreon.com/anthropoid. Otherwise, I hope to talk to you at some point this week. If not, I'll see you same time, same place next Sunday. See you there. Have a great week. Oh, and have a great President's Day if you're in a part of the world that celebrates President's Day. All right, see you guys. All right. Bye, YouTube. Thanks for watching.